So you can see that the aim is other configurations of polar equations of conic sections. And what I'm getting at here is that there are other configurations. For instance, we could have the directrix above, still horizontal, but above the x-axis. We could have the directrix being vertical and to the left of the y-axis, and we could have the directrix being vertical and to the right of the y-axis. And I'm going to see if you can take what we did yesterday. Yesterday we derived, as a little bit of a review, yesterday we saw that if the focus is at 0, 0, I know I'm calling it 0, 0 that way. I could also call it r theta, the pole. And the directrix, and you can see I'm mixing up, rectangular and polar all together, but this horizontal line can most easily be described as y equals negative d. And if we had some sort of conic, maybe it's an ellipse, maybe it's parabola, maybe it's a hyperbola with an eccentricity of e. We saw yesterday that the equation ended up becoming r equals eg over 1 minus e sine theta. And just as a reminder, because you're going to be doing this for other scenarios, we got that by picking a random point, calling it r theta, drawing this line, calling that r. This piece from here to here, this is theta. Theta always comes from the pole. So that piece is r sine theta, and this piece here is d. And the way we derived this formula was by using the property that the distance to the focus is e times the distance to the directrix. It became r sine theta plus d. And eventually that turned into this. Now, I made a sketch for this on Desmos that I showed you yesterday, but I'm going to bring this up again. So when we look at this sketch, we have the ED, I called it BD, but that B is kind of like the E, BD over 1 minus B sine theta. And you see just by changing B, which is really the eccentricity, we get the conic section, including hyperbolas. And I could actually change what D is also, and E. So in this way, polar conics are a little bit easier than rectangular conics in that they only have one equation that they all are based on. But it's very specific because the focus has to be at 0, 0, and the directrix in this case has to be y equals negative something. Now, for today's assignment, we're still going to have the focus at 0 at the pole, but we're going to see what happens. What would the equation have to be in order to get a directrix? Let's say I want to have like an upside down parabola. So the directrix would have to be y equals positive d. What would the equation be in those cases? And I have some questions on a sheet that I posted. The sheet's going to look like this. Let me go back to the iPad. There's, I think, 10 or 11 questions on this sheet, but the most important ones are numbers 1, 2, 3, and 4. 1, 2, and 3 are real specific, where you have directrix is y equals 6, eccentricity is 2/3. They all have eccentricity 2/3. And they all have focus at 0, 0. But I have 3 other positions of the directrix. Number 1 is a horizontal above the x-axis. Number 2 is a vertical to the left of the y-axis. Number 3 is vertical to the right of the y-axis. These are real specific. And then number 4, A, B, and C, have you try to figure out what should the general equations be? Now I'm going to try something kind of new and I hope interesting. I have here, and I want you to write this down because we're going to be going into the rooms in a bit. I have this Google form. And if you are on a computer, you could bring that up on a browser. Or you could write it down for now. Actually, why don't I just also type it into the chat. Okay, so I have here, I think you just click on it, maybe. Someone click on that, tell me if it works, if it gets you to the form. And then I'll show you what the form looks like and how we're gonna do this in the groups. Good. So I hear that it works. Now I am going to bring up that form. Hold on, new share. Okay, so now here's the way it's going to work. And actually, I can pause. Well, maybe people will want to hear when they're watching the video what we did. So what I have here, I'm going to put you into groups, and it goes randomly. So you're going to be in group 1, 2, 3, whatever. And then as you work in your groups on these 11 questions, you're going to, each time you answer one question, you're going to fill out, someone in the group is going to fill out the form. So you're going to put in what group number you're in. You're going to pick which question number. It's going to be a drop down. So there's 1, 2, 3, 4A, 4B, 4C, 5, 6, 7, 8, 9, 10, 11. And then 1 through 7 are short answer questions. So for those, you could just type in the short answer text. But 8 through 11 are graphs. So someone in the group will like take a picture and try to upload it. So basically, you have a group activity right now to try to do the 11 questions. Now you're going to talk to each other in these groups, and I'm going to jump around from group to group while you're doing this. So it's going to be a little more fun. I'm going to give you about 25 minutes to work in groups, and you'll be able to probably answer most of these, if not all. And then the last 5 minutes, I'll come back and I'll go over the answers. So it will be a little more fun, a little more sociable. I will be putting you into groups. Let me pause my video. Okay, I want to welcome everyone back to the rooms. And I'm going to go over the answers before we finish out. So hopefully for the first one, you found that it became almost the same formula, but it was ED over 1 plus E sine theta. Take a look at my diagram there. I drew, there wasn't much space to put it in, but I put the point in quadrant 1 as best as I could. And then this green line that you see on top there is actually, unlike yesterday when it was 6 plus r sine theta, that was 6 minus r sine theta. It's smaller than 6. But when you end up doing all the algebra, you end up getting a plus there. And this is why the answer, so the answer to this question was 4 over 1 plus 2/3 sine theta, or 12 over 3 plus 2 sine theta. But in general, the answer to 4A is ED over 1 plus E sine theta. So if the directrix is horizontal, it's going to be sine theta. And if it's y equals plus something, it's going to have a plus there. And if it's y equals minus something like yesterday, it's going to have a minus there. For number 2, see, I put r theta into the quadrant 1. There was a lot of room to do it there. But this time, I had to make a horizontal line segment from the point to the vertical directrix. So for this one, you see this line over here? I'm going to highlight it. This line there, that's actually equivalent to this line down here. So that's r cosine theta instead. And that's why it's r cosine theta plus 6, which eventually turns into, well, turns into this first, 4 over 1 minus 2/3 cosine theta. So if the directrix is on the left, a vertical line on the left, you're going to have ED over 1 minus E cosine theta. So if it's x equals negative something, you're going to have a negative there. And you might have suspected then that the last answer was going to have a plus there and a cosine. And it does. The picture for it's a little bit tricky on this one. The r theta I put over there. And that green line segment is smaller than 6. 6 is from here to here. That green segment's smaller by this little tiny amount. I'll use a different colored highlighter, by this small amount. But that small amount is also this, which is r cosine theta. So for our purposes, what I hoped you got out of this, and you did with your groups, and I popped into the different groups. I liked what I was seeing and hearing. I think that made this a lot more fun. Be prepared for me to do that in future days. Here are the other 3 scenarios now. And an easy way to remember it is, up, down, it's going to be sine. Left, right, it's going to be cosine. And as far as the plus and minus goes, if it's y equals plus something, it's going to be, or x equals plus something, there's going to end up being a plus in this spot here. And if it's y equals minus something, so it's under the x-axis and it's horizontal, or x equals minus something because it's to the left, it's going to have a minus there. Here are some other answers. Maybe for this conic, we know what E and D are. And then we just plug it into the ED over 1 plus sine theta because the directrix was above the x-axis. This is left-right with the cosine with it x equals negative, so we should get a negative there. E is 3/4, that's given. D we could see is 4. D is never negative. D is just the distance, so it's 3 over 1 minus 3/4 cosine theta. For this one, it's left-right, but the directrix is x equals plus, so there should be a plus here. ED over 1 plus cosine theta. Now for the graphing ones, what I like to do is first I get it into this form by dividing everything by 5 to turn this into a 1 here. Then I can see I should expect an ellipse because the eccentricity became a fraction. And I could actually work out, make sure I did something right. So E is 4/5 and 4 is ED. So ED is equal to 4/5 times D is equal to 4. So D is 5. And because of this plus here, it's directrix up here. Then if you make the 4 points, everything seems to make sense. I know that 270/20 is kind of low off the graph. In this one, after dividing everything by 4, it became this. So E was 5/4. D ended up becoming 4. This is the kind from yesterday. So it's going to be horizontal directrix at y equals -4. And when you plot the 4 points, 1, 2, 3, 4, if you know it's a hyperbola, the one that's under the directrix is going to be the vertex of the other branch. And for this one, it's going to be a left-right one. It's going to be parabola. And D is 6, so it's x equals 6. And the 4 points give us the 4 points, or the 3 points actually, together with the knowledge that it's a parabola. Let's just draw this picture. And finally, the last one, well, that's also from yesterday. That's the kind that we did yesterday with the ellipse. Okay, well, that's what I wanted to show you. Let me, there's a bunch of stuff for homework, including a Desmos activity builder and some textbook questions. Let me pause the recording or stop the recording.